2.1, this is about energy profile diagrams and exo and endothermic reactions, mainly exothermic because we're doing combustion reactions. So if you're asked to explain energy transformations, it means that you're turning one type of energy into another type of energy. What are the 5 different sorts of energy? Okay, so there's light, heat, chemical, kinetic, movement, and electrical. We are primarily going to be interested in the bottom ones. So chemical energy being converted or transformed into heat energy. So that's what exothermic reactions are. Chemical energy in fuels, and when you combust the fuel, turning it into heat. And chemical energy later on when we look at batteries, turning it into electrical energy. And electrical energy back into chemical, back into battery, recharging batteries. Different sorts of chemical and physical reactions. Just pause the video here and try and write down as many as you can, and then I'll look at it. Okay, so chemical reactions. Condensation reaction is where you put 2 molecules together and they produce water. And hydrolysis is the opposite of that, where you're breaking one large molecule by adding hydro is water, and lysis means break. So you add water and you break it back into 2 again. So the opposite of making an ester. Addition reactions, when you've got a double bond. So you break the 2 double bonds and add the 2 molecules together. Polymerization, where you've got monomers and you can add them. If you've got a double bond, just add the monomers one after another. Or if you've got a molecules, functional groups on either end of the molecule that can undergo a condensation reaction, then you can also produce a polymer. Dissolving, so just adding ionic compounds to water or acids to water produces heat. So the reason that we're interested in all of these is they either produce heat when they happen or they take in heat for them to happen. Precipitation reactions, when you add 2 ionic solutions together. Acids and bases are generally exothermic, giving off heat. Acids with metal are exothermic, giving off heat. And then all our redox reactions. So these are the opposite of each other, photosynthesis and respiration. Photosynthesis, you're taking the energy from light energy to make chemical, and respiration, you're using chemical energy to perhaps make heat or make movement. Combustion reaction is highlighted in red because that's the main one that we're interested in. It's also, these reactions that we know by different names are all redox reactions. And then you've got your physical rather than chemical, so just changing state. So changing from a solid to a liquid, or from a liquid to a gas, or back from a gas to a liquid, from a liquid to a solid. All of these obviously require heat or lose heat. So that's the whole point. Some release heat when they happen and some take in energy. So you need to take your own notes from the textbook if you read over pages 36 to 40. So what is chemical energy? It's kind of a whole lot of things. The chemical energy of a substance is the sum of its potential energy, so stored energy in the molecule, which is generally because you've got one atom bonded to another atom, and the bond, the electrons between them, will have different amounts of energy depending on the type of bond, whether it's carbon to carbon or carbon to hydrogen or a double bond or that type of thing. They'll have different amounts of energy stored. And it's kinetic energy, so the movement of the bond, so how one atom moves around another atom, how they twist, bend, flex, and then how the whole molecule itself can move around other molecules. So all of those things together is what chemical energy is referring to. So the chemical energy of a substance is sometimes called its heat content or enthalpy. So we call H enthalpy. So Exothermic reactions are when heat is given off. Exo, like exits, given off. Endo, like coming in, so you take it in. And thermic is referring to heat. So a thermometer is something that measures heat. Easy one. Is it exo or endo, this type of reaction? It's a combustion reaction. It's obviously exothermic. It's releasing a lot of heat. Exo or endothermic for this reaction? It's endothermic. You need to take in heat to change state, to go from a solid to a liquid. Is it a physical or a chemical reaction? It's a physical. It's a changing state. Which has more energy, the starting, the block of ice, or the liquid water? If you've taken in energy, then the liquid water must have more energy than the solid. You need to obviously have your states on here, because that is a reaction going from a solid to a liquid, and the water as liquid has more energy in it than the water as a solid. What do you call a collection of reactions happening inside the leaf? Exo or endo? So it's photosynthesis that's going on inside the leaf, and it's endothermic, taking in energy. What reactants do plants use? Remember, carbon dioxide and water to produce sugars. Which group has more energy, the reactants or the products? So if it's taken in energy, then obviously the sugar and the oxygen have more energy, the sugar in particular, than the carbon dioxide and water. If you wanted to see if a reaction in solution was endo or exothermic, what equipment might you need? So you're measuring the heat that's been released or taken in, so you need a thermometer. What units is energy measured in? Joules or kilojoules. So if you're measuring something in degrees, then you're going to need some equation to convert it to joules or kilojoules, or 1,000 times. So a kilojoule is 1,000 times a joule, and a megajoule is 1,000 lots of kilojoules.